عليكم ورحمة الله وبركاته. اليوم بنزل لكم فيديو عن خصائص النيتروجين وعن تجربة رحناها في الجامعة. خليكم مع المقطع، والمقطع تأخر شوي في التنزيل بسبة رمضان نوم. يلا شوف المقطع.
Cold, so it's humid in this room. When I pour it out over our water especially, you're going to see that water vapor again condensing into tiny droplets that form clouds. So we'll see clouds. But you might also see that it pours just like a liquid does as I pour it over our regular water. And what we have left is a cloud. Exactly the same as the clouds we see in our own sky. Now, to cool this down to negative 320 degrees, it's actually a pretty difficult thing to do, but the properties of a liquid nitrogen as compared to the normal air in the room are quite different. In the same way that the steam, I spilled a little bit, but that's okay. That should do. I poured a small amount in. You can see it boiling on the bottom. I'm going to go ahead and put our plug on the top. And you can see that as it boils, here we go, as it boils, the volume of that liquid nitrogen that turns into a gas will expand. And it's probably going to expand enough to make that balloon pop. We'll just let it go until it does. But you can see, again, it was just a small amount of liquid nitrogen that I poured into the vial. It's now enough to fill up that balloon easily enough. And it sounds like it's about to pop. Should I try and stop it, or should I just let it go? We'll just let it go. We've gotten this far, right? It's the biggest balloon I've made so far. But again, that gas, it takes up a huge room compared to the same comparable amount of liquid. So one of the things that becomes really, really helpful with that, for example, scuba divers, when they want to have enough oxygen to bring with them, they'll actually compress oxygen into a small tank. They're not actually turning it into a liquid, but they're able to compress it to a much smaller size if they're using a heavy metal tank. Another thing that we can actually do, for example, if we want to take air up to space, when you're at the International Space Station, you actually have less air at the International Space Station in their rooms with them as we do in the planetarium room right now. So they have to actually replenish their oxygen when the astronauts are living there for a long time. And one of the ways to do that, and I don't know if we are going to pop or not. We'll just leave it as a fully. You hear the air rushing out of there. One of the things that they can do, rather than taking up air when it's this size, when it's in a gas, which means the temperature of liquid nitrogen. So I'm going to pour some out into this dewar right here. Again, you can see it pours just like, it looks just like water. And it pours just like a liquid. You'll hear it boiling, just like if you were boiling a pot of water on the stove, because this dewar was room temperature. And that's way past the boiling point of liquid nitrogen. So you hear it boil until it turns the rest of the dewar. It's still boiling there, it looks like, until it cools down the dewar to negative 320 degrees Fahrenheit. So we're going to do a few different tests about what happens to the material properties of things. And what we have is, well, I have a rubber hose right here. And rubber is a material we're all familiar with. Let me take off my watch, I won't need that. Rubber is flexible. It frees this rubber hose down to negative 320 degrees. So as soon as I put the hose in the liquid nitrogen, you can hear it boiling again because this hose was at room temperature, which is almost a 400 degree difference from the liquid nitrogen that I'm sticking it into. Once it stops boiling, we'll know that the hose has cooled down to about negative 320 degrees Fahrenheit. And I can see it's still boiling there for a little bit. Does anybody have any predictions about what's going to happen to the hose? Will it still be flexible or stretchable like it was?
No.
We'll find out. Alright, so it's mostly stopped boiling, so I think we're probably good. It probably means it's cooled down. As I take it out, you might notice that there's a kink in the hose and that's still stuck there. It looks just like a normal hose. It looks exactly the same, but I can't bend it anymore. I can't stretch it anymore. And let's see how it sounds if I hit it against the table. It's almost as if this is turned into a hammer. as it spends more time with the moisture in the room, you can see water droplets that are cooling to condense around this because, again, it's still negative 320 degrees. But the other fun test is what happens if I just set this hose on the table and we wait maybe 5 minutes. Well, when it returns to room temperature, will it be back to being a normal hose, or will it be forever changed by merge this balloon completely? And remember, what's in the balloon is air, just like the air in the room. So that balloon is mostly filled up with nitrogen. So if we cool that nitrogen, the air in the balloon, down to negative 320 degrees, well, it should turn into, or at least become very similar to, a liquid. So that's stopped boiling. I'll bring our balloon back out. Get rid of all that extra nitrogen on it. All right. And you can see our balloon's all crumpled up. It looks like it's deflated. But as it returns to room temperature, it's beginning to expand again. It's actually frozen now to this. So I froze our grabbers to it. So it's actually, there we go. Oops. It'll eventually return as it blows back up. It'll return to room temperature. That's again, that's the nitrogen, and you can see it sort of puffing out the tail now. That's the nitrogen just expanding back to being a gas when it had been compressed down to almost being like a liquid before. So our rubber balloon was okay. Our hose is returning back to room temperature, which means it's bendable and flexible again. What would happen if we took something a little bit more complex than the rubber that makes up the balloon, or the rubber that makes up our rubber hose that we were looking at? What happens if we took light and we instantly froze it down to negative 320 degrees? Would it return back to normal? Actually, take my hand out of the glove as well. So I have these peonies. I usually do this with roses, but I didn't find any roses this morning when I went to the store, so hopefully this will work okay. I'm going to go ahead and freeze our flour down. Again, you hear the flour is warm like room temperature, so it will cause the liquid nitrogen to boil around it. Oops, there goes our hose. Once the flour stops boiling, that means it's been cooled down to negative 320 degrees.
That's a wood بخير.
You can probably still hear it's bubbling sort of like a cauldron right now. And what will happen to this flour when we take it out of the liquid nitrogen will be pretty analogous to what would happen to, for example, my hand if I decided to stick my hand into the liquid nitrogen and leave it there to reach negative 320 degrees. And we'll find out whether or not that's a good thing in just a minute. Does anybody want to volunteer for this next part? When we're talking about freezing life down to negative 320 degrees. I see one person with their hand up. You want to come up?
دخل يدي وسط.
So don't worry, I'm not going to stick your hand in liquid nitrogen. If I give it a squeeze, you'll notice that it's totally flexible. It's totally okay with being squeezed. But when frozen flour, it completely shatters. And actually, I think that's going to be good. We might be able to freeze some more flour, so you can head back to your seat. Thank you. Happen to your hand if it's out in cold weather for maybe half an octet or something. So for example, if I pour some onto the carpet here, it instantly boils when it hits the carpet. So, and you get to see that cloud again. And actually, I won't do this with you guys, but just to show you, if I pour some liquid nitrogen onto my hand, again, it instantly boils when it comes into contact with something warm. So, it's totally okay. My hand's totally okay. That's because a small barrier of the boiling liquid nitrogen actually kept my hand coated.
ينصح الخبراء اليابانيين باتخاذ الإجراءات التالية: سبسكرايب، لايك، كومنت، فيفورت.